so you probably know that building a prototype, so coming from prototype to a production-ready system is quite a long way. So today we want you to present our journey, how we built our fraud detection system from a pretty small prototype to actually a good fraud detection system. But first, let me introduce ourselves. This is Max. I'm Dima. We work together in fraud detection, fraud prevention team at TransferWise. So,
okay. First, let's keep a bit of context. Before we go into details, let me talk a little bit what is fraud. So fraud is a quite wide topic. You can talk about all night, and just listing how it can be done and what to do with it. But let's not spend whole evening on that. For us, most common pattern of fraud is I forgot. Identity theft, thank you. So identity theft happens when there is a fraudster. He creates account in TransferWise using some other person details, and then tries to transfer money of the victim to his own account and outside of the country to make it easier for him to get away from police. By the time he creates account, usually actual crime already happened, and fraudster has access to victim's money account, credit card, or something else. So how do we detect that? How can you detect this? There are two good ways of doing that. First, check if it's a known fraudster. Thank you. I've asked, nobody knows that guy. So it's a known fraudster. How can you do that? You just go look into profile and find some features which link people quite tightly. Something like bank account. If two people are using same bank account, it is very likely that's the same person. So if we know one is fraudster, other one is obviously also fraudster. Second type, just check whether transfer makes sense. Let's take an example. We have a customer, imagine a customer who claims to be an old lady, 89 years old, lives in UK, nothing suspicious. There are tech-savvy grannies out there, especially in UK. Then she logs in from Latvian account. Okay, Latvia is a beautiful country, maybe she's traveling. Nothing too suspicious there. Then she creates a transfer, and she transfers money from UK into India. Well, it also happens, might be she has some relatives in India, some grandson or something, especially Britain, long relationship, you know. But then, what's the reason for sending this money? She buys Lada Kalina. Well, after that, you probably start thinking something is wrong with that. Maybe it doesn't make sense. Potentially fraud. So this is how you look at that. But who does that? Let me talk a bit about our team setup. So first of all, people who are identifying fraud are fraud prevention agents. We call them fraud agents. They are actually looking at those guys and try to separate good guys from fraudsters. Well, since we're grown a bit, it's no longer possible to just look at every customer and every transfer. So we have also fraud agent, fraud engine. It just does the check and filter out good guys, everyone who looks suspicious, and to fraud agents to review. And as you probably guessed, when there is an engine, there should be an engineer. So we have engineering team who actually are us, and we're building that and tuning. But for engine to run smoothly, we have another group. Those are fraud analysts. They are working tightly together with fraud agent team, and they also look into data patterns, trying to identify some patterns and tune agent, create new ways of identifying fraud. Okay, it looks nice, but it wasn't always like that.
So, a year ago, our team was quite different. We had agents, we had the analyst, and no developers at all in the fraud prevention team. So, the engine was solely built by the analyst. And it was running quite well until we launched US, because this is probably the most fraudulent route in the world. At some point, the analyst decided to concentrate on his own startup and to leave TransferWise, and we needed to take over the ownership of fraud detection engine. And what we inherited, it was quite an archaic setup. We had no documentation, no version control, almost no logs, one class of static methods, and just a bunch of PHP scripts running in production using frontend. Quite fun. So we were literally fixing code in production to survive. From another side, the system was simple as brick. We could understand what it does, and PHP was offering us quite an astronomic release cycle. We could release like 10 times a day or more. Also, modern PHP didn't seem like that bad language as it was before, and you can actually code Java-like style OOP in PHP. But the actual problem was that we had no idea what to do with that, because we had like a piece of code, we had some knowledge about fraud, what it is, and we've done some courses on Coursera about machine learning, and that's it. So we decided not to rewrite. It was quite obvious for us. But to fix it and learn. But what to fix was the actual problem, and how to prioritize what to fix.
Thank you. So when you don't know what to fix, you just add monitoring. In our case, we knew what to fix, everything. But the problem was what to fix first, what is burning the most, what is about to explode. So first thing that we did is we added Bugsnag. If you don't know what Bugsnag is, it's an error monitoring tool. Basically, it's some kind of plugin that you attach to your application, and it sends all the error notifications into some tool. Don't talk about that. It's really good because you're getting production data in nice interface, and the best part of that is that it groups errors. And this is actually really helps to prioritize issues, because if you see that something fails 10,000 times a day, well, probably it's something important. So we integrated Bugsnag. We choose Bugsnag because we already used that in other projects within company, and it works pretty well. So we turned on integration, and what did we see? Bugs, gazillion of bugs. Basically, I cannot even tell how many were there. There was hundreds and hundreds of them. And well, when you see what is important, what is not, you start fixing. We spent a couple of weeks doing that, maybe a couple of more then. By some time after that, we had just small issues visible, but for some reason, engine was still failing and something was wrong. We still got loss. We still had angry fraud agents that had too much work to do. So we did next step, and we introduced charts, monitoring charts. I basically adore those things. We started, Dim already mentioned that we had cron jobs that were doing a lot of stuff. So we added monitoring for each of them, created charts. They were ugly, they were in Zabbix, something you don't want to see, but you will. And then it turned out that half of the jobs were failing silently. Some of them were dead for days. Others had happy hours in the nights for fraudsters. They were just stuck. And yeah, that's a pretty good insight. And something doesn't work. Basically, this is how they looked. You see? They're ugly, but they work perfectly. You can make pretty graphs, you can spend a lot of time on that, but this works just as well. What I would advise is not to spend too much time on bringing numbers. Those patterns that you see, brain can recognize when something goes wrong really well. And another thing, if you're doing that, if you're not doing that, create those graphs, but they only work if you have that in front of your eyes. So get a TV, put it on a screen, it works really well. Don't make it so that you need to do additional click to see that something is wrong. Well, we fixed those issues as well. So what happened? Everything got better? No, everything got worse. And why? Because now engine wasn't failing. And since it wasn't accurate at all, it was sending tons and tons of good customer for manual reviews. Customers unhappy, agents unhappy because they have too much work. They have to work at night. Next step is not so obvious. We introduce rule confusion matrices. So what is rule confusion matrix is, well, it's a thing. It's things like that. And it is used in machine learning to measure performance of algorithms. And not actually measure, to visualize. There you have columns. Columns represent predicted values or predicted classes by your algorithm. In our case, it's pretty simple. Our rule says it's fraud or not fraud. And lines represent what it actually is. So if we predicted fraud, and it is fraud, we get true positive, TP on the slide. No, I won't use it. So if it's predicted to be not a fraud, but it actually is, then it's false positive, and so on. What it gave us a really good visibility of each rule that we saw that if we have a lot of false positives on a rule, it means that a lot of, okay, I will finish then. If we have a lot of false positive, then rule doesn't work in the way that it sends a lot of good customers for manual review. If we have a lot of false negative, it means that rule doesn't work in the sense that it misses a lot of fraudsters and we're getting losses. Yes?
I'm confused about this confusion matrix. Can you give an example of this rule? Like,
rule?
This, then it's a fraud.
It will be in the few next slides. Let me...
Just 3 slides away.
So, and when you have this visibility, you can also derive some kind of new values like precision and accuracy that gives you just one number to track. And it's really helped. After what we got as a result is that after we reviewed all our rules, it turned out that 30% of them were worse than random. And one was particularly good. I adore it. It was so bad we had to invert it to make it good. So actually it still works. It's really good at catching fraud. Well, it's not always like you expect. So, fraud engine.
As we started speaking about rules, I want to speak about our fraud engine and what it consists of. So, it relies on three main pillars. It's static rules, token models, and relations. Everything, they process and evaluate data gathered by data gathering module, and forward their output, their decision, whether it's fraud or not, to scoring, which composes it together and makes the actual final decision. So the simplest of them is static rules. So remember our example of old granny from UK. So if we could compose a rule that could catch the grocer and that was trying to fraud this lady, what we could compose, let's say if the age is more than 80 years and the target currency is INR, we could catch that guy and save money for Her Majesty. Yeah, stop it. The rules are simple. They're simple to implement, they're simple to understand, and this piece is really important for us because when agents receive an alert about suspicious activity, they need to understand why we suspended that. And this is where rules are good at. Also rules, you don't need to train them. You don't need prior data to actually compose a rule. You may use just an expert knowledge of agents and analysts and compose rules. From the downside, they're outdated really quickly. So fraud evolves in patterns and in waves. So if there was a wave of some kind of fraudulent pattern coming from USD to INR, for example, but it's no more, the rule starts catching only good customers. There are, however, means to fix that. We have so-called token models. Why they call token is for historical reasons. If we have time, I can explain, but I believe it's just token models. So imagine a two-dimensional space. It's a simplification. On x-axis you have amount, on the y-axis you have source currency. It's a currency where a customer is transferring money from. So, and we can put a good customer on that plane. Let's say if he's transferring less than 1,000 and it's euro. We can also put another customer who is a good customer, who is transferring more than 1,000, and all others. And we may repeat the same procedure with fraudsters. Now, when we have all these sectors or areas, we can compute for each area a ratio of fraudsters to all customers. And if we set up a threshold, let's say 0.5, we may mark some areas as fraudulent, and every customer who hits that area, we mark as fraudulent. So these models are still simple. They're simple to understand, and another thing, they're really simple to implement. You can actually write a single SQL query, even MySQL, to train that model. This is very important, especially for startups and small companies. You want to move fast, and you don't want to invest a lot in infrastructure. Machine learning infrastructure is quite huge, usually Hadoop and stuff. And you have just SQL database, you can do that there. It's simple. Also they, unlike static rules, they're automatically retrainable and respond to new fraud patterns. From the other hand, as any machine learning, token models require some prior examples of fraud to train. Also, you need to compose all features for the model manually, choose them, bucket them, and so on. And comparing to other machine learning, true machine learning models, these models overfit badly. If you throw in too many features, and they really suck if you put too few. And many can call that also a disadvantage. They're not scientific. There are no scientific background behind them. And another technical problem that at some scale they stop working because there is your database, you're running SQLs against one database with a group by, huge group by, and it won't scale. And the third pillar is relations. So if you have, for example, an IP address of a user, and you have 3 users using the same IP address, 2 of them good, 1 is bad, and you want to determine whether the guy is good, the 4th guy who is coming with the same IP is good. You can again define some ratio, let's say 0.5, and in this case he will be good. But if all guys are using the IP are bad, then he is bad. So all these mechanisms and models are not working well on their own. We need to somehow combine output of them to something more general. For that we have scoring system, and each rule, token model, and relation has some kind of a score attached to them. We add them all up and compare the threshold, and if it's above, if it hits, we suspend the payment.
Well, it's all nice and scientific, and actually not scientific, but it works. It's really interesting to work, but it doesn't work if you don't have good data supplied to that. And unfortunately, gathering data and making sure it's good is 80% of the work. So we don't have too much time. So on that, it's a large topic on its own. So I will just mention a few hints that we learned while improving our system. In the beginning, our data pipeline looked like that. We have basically fraud detection engine running big-ass SQL against slave database and gathering all the necessary information to make decision whether user is fraudulent or not. Well, as you imagine, this kind of solution has tons of problems. Every time, unless you do really careful releases, every time database schema changes, you have something broken. If you have a lot of data, if you have rapid growth of your database, everything stops working because it becomes too slow. When you need to add something more trickier than just data, some aggregation, everything becomes slower. Well, yeah, but you know, that's not surprising. What was surprising that how well it worked before it stopped. Actually, it is really cheap to implement. It's fast to add new data. If you know how fast you grow, you can actually predict when it stopped working. So again, if you're a startup, this might be a solution. But you need to know a few tricks to make it work. One of those, do not use slave or failover database. Why is it bad? Well, because it's a failover database. If something terrible will happen and master database fails, you have nowhere to switch. You can switch your application, but fraud engine will stop. Well, you might say it's kind of obvious, but half of companies out there are doing that. It's a bad thing. Another thing, you see this backup store and nightly job? For us, well, slave database usually have those. And for us, it meant that during the night, when backup job was running, for an hour, fraud engine was stopped because performance hit during backup was so terrible. Don't do that. Better setup would be something like that. So when you have slave database and you have separate replication done for all your other needs, for analytics, for fraud detection, anything you need. Another thing, well, we had to, one of the challenges for us was to reading new data since last check. What happened? Since database is not a queue, it's kind of, you need to learn some tricks. And what we did, we did the obvious thing. If we have database that is write only, no updates, you remember last process ID. If it's insert end update, then last update timestamp. It seems like it should work. Well, there are a few caveats with that. First, you cannot trust last updated if it's not set by trigger. Because if it's not set by trigger, that it's object relational mapping that's setting it. And if you have more than one machine, times on those machines might be synchronized by NTP, but they still have slight difference. And this slight difference might mean that last time you check record, you have some ID, not some ID, some timestamp, and next commit will insert last updated with a smaller timestamp. So you will lose some data. Second thing, you cannot trust IDs as well. And thing is more complicated, a little bit more complicated with that. Imagine you have two transactions, transaction A and transaction B. Transaction A starts, then it does insert into the table value. At that point, if you're using auto increment or something like serial type, you will get an ID. But then happens something else. Another transaction starts, and it also does insert, and it commits before. In transaction A, you have value, let's say 1. In transaction B, you have ID value 2. And it's committed, it's already visible. If next thing, what happens, if you read from this table, you don't see value ID key and you save this value. So you think you process everything till ID 2, but you haven't, because commit happens only later, and now you can see this row. It's a problem. For us, since we're dealing with statistics, we can ignore it for now. We did some research, we experimented, and actually with large enough numbers we can bear the loss of data. But probably if you have something like that, you need to think about this. Future.
So we've pretty much grown the solutions we described here, and we already invested quite a lot, and bought us some room to breathe and actually to think about more general picture and to think about our future. And currently, we're already working on some to make our engine better and to introduce actual machine learning there. All the different stuff, you know, Spark, Kafka, all these things. It should be fun. Sometime next year, I think we'll share something completely amazing Yes. Yeah, thank you very much. Q&A.
Who-
Someone can orchestrate that? Or,
I guess without microphone is just as good.
okay. Shall
So how much fraud do you detect these days, and what's your success rate?
About 1% of all our transactions are fraudulent.
Can you give me a number? How much is 1%?
No.
It's not disclosable. Sorry.
Basically, it's 1% you know that the fraudulent. You think.
When
The rest you
when
don't
we
catch.
So when fraud is happening, the ground truth for fraud detection is when we receive chargeback. So the real person behind that account sees that, oh, this is not what I did, and it commits a chargeback at his bank, and that's when we get lost, and we have that information. So 99% of people look into their bank account and know what they do. So we always receive that data, and we know for certain that after 1 month we pretty much sure that we got all the fraud.
So what's your false positive rate then?
False positive rate. No.
There was a question over there, two questions.
Yeah, I had a question with the metrics. So you have these pillars, and how do you sum up the whole thing? Is it like you have 100 rules in one column, in one column, and I don't know 100 models in another, and you just linearly sum them up?
Yep.
Do you have any coefficients or something?
No. We don't have. We know that it creates some problems, but well, this is what we have. It works so far, but actually in next few weeks, I guess we will be switching that to ratio or fraud coefficient. So this is.
Are you going to make like a neural network to have them dynamically change based on the?
So neural network is too complicated to understand from agent's perspective. I mean, you can't understand human being can't understand what it gives you as an output. So what we are going to try is there are basically all quite established things as random forest. Another thing is really simple is logistic regression. So those things that are like in our queue for trying.
Okay, and second question, so you have this grandma who's trying to send money to India to buy a car. Why is it a fraud?
It's not, but it's suspicious. And if this is a root cause to ask this grandma for some kind of verification, or just call up and check whether she speaks with Indian accent or not. So
you don't block her out totally, you try to get more info, or?
well, this depends on the agent. Agents, fraud agents, they are trained to detect and spot this. And if they can confirm that it's fraud, we'll block it. If it's not, then we might just monitor. If it looks legit, then we just pass.
Third question.
That's the last one.
Do you use less data outside of your TransferWise? Like, do you have a database of fraudulent guys from each country or something like that?
I can say that we use partner data.
So
I cannot share more.
Okay, the guy right behind was two.
I have actually 3 questions.
Can you go with one, please? There's like a question, Q2.
Yeah, okay, very quickly. As first, confused. Do you start running the fraud detection at the moment the person is doing the transaction or creating the transaction, or is it nightly job?
It's triggered by events. I will not tell you which events, but it's not like a batch nightly job. We don't wait for that because some of our transfers happened instantly, and we need to know right away.
Yeah, so it's instant.
So this person starts to create a transaction. You check that the IP, you compare with your previous IPs, and you know that this person has some occurrences from their different profiles. In this case, you say, okay, this person might be a fraud case. In that case, do you let him through and not notify anything, like silently let him finish the process, but in the background you know that he is a fraud case, or you stop right there?
We never tell fraudsters that they're fraudsters.
And in that case, do you report them to fraud? Do you bring them to court, or do you process them legally, or just?
We do the necessary.
Yes.
Okay, there was a question here, please.
Yes, you say that when you receive a chargeback request from bank, it's a fraud. But what about cases when it's a fraud about fraud? Like someone made a payment, received the money, but then said what it was a fraud.
It's in our cases, but it's generally called friendly fraud. So friendly. This is much rare, but quite an unsolvable problem. Almost no ways to detect that.
Question here, please.
Okay, technical question for a change. So out of curiosity, did you just implement your own rule engine, or are you using some kind of industry standards?
Yes.
Own one?
Yes, what?
Home.
And as a follow-up, what is the main reason not to use rules or something like that?
I think it's simplicity, first of all, and for historical reasons.
Okay, that explains it. Thank you.
There was one question over there.
So, still running PHP?
Yes.
Thank you, that was quick. Here.
How has fraud evolved over time in TransferWise? From when you started to where you are now?
I'm not sure what do you mean. We kind of try to explain how fraud engine in team evolved, or fraud.
How much fraud did you have when you started, when you had the first system, when you had the new system?
Well, when we had first system, it was a crisis. We had, if we wouldn't stop it, we would have to close USD. That, and there were a bunch of other crises which would force us to stop working with some of our partners. Now, we're okay.
The last question was, well, actually,
We are that okay that we can invest in something new.
one question was there. Yeah.
Yeah, one question. You have mentioned that you have had so many issues with the database, with reading and logging and stuff like that. Have you considered publish-subscribe pattern to use? Just to subscribe to events?
Yes, we have considered that. Actually, this is still our plan to move to that, but compared to what we have now, this means that every piece of the TransferWise system and other subsystems should send those events. And this is, compared to what we have, it's a significant effort, and this transition is not easy. So far we were till this January we were trying to stabilize. Now we're moving forward.
Okay, the last questions.
I follow up with the current approach of reading like the last ID and like everything from the last ID. We are losing like much less than 1% of data. Which for us means almost nothing. And since it's much cheaper approach to extract data from the database, there was no like good reason to switch until now.
Okay, and the last question.
From this 1%, you can see that fraud transactions How much did you got back through police investigation?
1% is not succeeded, it's tried. So 1% of users are marked as fraud. But the actual fraud that was committed and was successful is much lower. Regarding police, police is not that interested actually in handling all these problems.
Or financial institutions. I mean, financial inspection.
We notify all the needed parties, but what do they take care about that? Not always, unfortunately.
Yeah. One more comment. We also have a team that actually tries to recover money, we have a team that tries to recover money. They work with bank institutions, sometimes contact customers if it's friendly fraud, and most people actually, if it was a mistake or they just use some opportunity, they are good people and they return money.
All right, thank you guys. All the other questions that still remain unasked can be asked in private. Thank you, guys. It was great.